first problem. So here it is asking, what is the slope of the graph of y equals 12x minus 19? Now, this, first of all, anytime I see this in slope intercept form, whatever number is attached to my x is going to be my slope, meaning my correct answer is going to be answer choice D. If I wanted to, I could verify this by looking at my formula sheet, and I'll see that that m, the number that's attached to the x, is my slope. All right, let's go ahead and take a look at number 2. A golfer hit a ball from a tee box that is 6 yards above the ground. The graph shows the height in yards of the ball above the ground as a quadratic function of x, the horizontal distance in yards of the golf ball from the tee box. Okay, way too much information, okay? We don't even need to know all of that. What is the domain of the function? Domain is dealing with x's, not y's. So I already can eliminate answer choice G and H. So I look at it and say, all right, what's my domain? I'm going to go way over here. I'm going to get my little line or my pencil to do my domain test. It's going to hit at 0 and go all the way up to positive 230. So that means that F is going to be the correct answer. Now, down here, they were banking on you not knowing that that 6 is part of the range. That has nothing to do with my domain. Okay? Let's take a look at number 3. Which value of x makes the equation true? So, first of all, there's lots of different ways we could go about doing this. I'm going to go ahead and solve this one by hand. Now, if I go ahead and distribute this, it is going to cause decimals to appear. Okay? I could go ahead and divide, see what happens there. So I'm going to go ahead and divide just to get rid of that 1.25 because I'm trying to avoid creating decimals. Okay, now I can do exciting move, great divide, in order to get this x by itself. And I end up with a value of x equals 4. However, I just want to verify this utilizing my calculator. So let's go ahead and swing over to the calculator. I'm going to open up a new calculator page, and I'm going to get one of those NSolves up and going. I'm going to go ahead and type in the original equation exactly as it appeared. And I'm going to say, hey, you're looking for the variable x. It gave me back exactly the same answer. So I got that one correct. Next one. Here they're asking me which one of these functions is equivalent to this. Well, to me, it looks like they factored. So they want me to factor. So let's go ahead and do that. So first thing I do whenever I say this is I say, all right, is there any greatest common factor that I can go ahead and pull out? There's not. My a value is positive 1. There's nothing to take out. So I'm going to multiply a times c, which is negative 54. I need two numbers that when multiplied together will give me negative 54, but will add together to give me positive 15. So negative times a positive makes a negative, and that means that I'm going to have one positive, one negative. And over here, when they add together, they're still positive. That means that the positive number is bigger. So I'm going to go ahead and start by looking at all my different options. So I'll say, let's see, negative 1, positive 54, no, negative 2, 27, no, negative 3, let's see, 18, yes, those are my numbers. So let's go ahead and split apart that B value. And I'm going to go ahead and factor out from just the first set. Now I'm going to factor out from just the second set. I'm going to ensure that the insides are exactly the same. And then and I'm going to combine like terms. Now I'm going to go ahead and look, and it appears as though answer G is the correct answer. I just want to verify this. I want to make sure that their two graphs match. So I'm going to go ahead and I'm going to swing over to my calculator. And I'm going to go ahead and open up a new graphing page. And I'm going to say the function from number 4 is going to be x to the power of 2 plus 15x minus 54. All right, so it should look like that. Of course, I can zoom out a little bit. I'll do a zoom fit. So it's got to look something like that. So let me go ahead and hit tab. And I'm going to go ahead and put in answer choice G from question number 4. And that's going to be x plus 18 multiplied by x minus 3. And that needs to be a lowercase. All right. And look at that. It lays directly on top of it. That means that we did our math correctly and we got the right answer. Let's keep moving on. All right. The table shows the linear relationship between the average height and feet of trees on a tree farm and the number of years since the trees were planted. What is the rate of change? So I'm going to go ahead and I'm going to solve this numerically first. Let's go ahead and put that into our slope formula. Go ahead and get these written in. And we can go ahead and get started on simplifying. And I find out that my rate of change is equivalent to 7. My answer is C. But I just want to verify this. I need to input my x's and my y's into my calculator and run a linear regression. So these are my x's from question number 5, my y's from question number 5. And I already previously typed them in. So I'm going to go ahead and run my regression. I'm going to do linear regression, y equals mx plus b. I am going to select the x's from number 5. Where did they go? All right. Oh, no. Okay, hold on. There we go. All right, my x's from number 5. Notice how confusing it is if you don't label these really good. And look at that. My slope is equal to positive 7, exactly as I predicted. So we're correct. Let's take a look at the next one. What is the equation in slope-intercept form of the line that passes through these points? All right, so I can run a regression, get the equation super quick. I'm going to go ahead and do it by hand just to make sure I don't get rusty. So first thing, I'm going to calculate that slope. 6 minus 2, all divided by 12 minus negative 4. My slope is 1 over 4. Now I can pick either one of my points. I'll pick the two positive ones, and I'm going to use point slope form. Y minus blank equals slope times x minus blank. All right, 1 over 4. And over here, I'll go ahead and put in my values, 6 and 12. And now I can simplify. Y minus 6 equals 1/4 x minus 3. I can add my 6. And I end up with my equation, y equals 1/4 x plus 3. F. Noticing that my point slope gives me my equation directly. I just rearrange. Kind of feels like it saves a step, although I feel like it's the same amount of steps. But I'll go ahead and verify this in my calculator. I'm going to start a brand new linear regression. This is going to be my x's from number 6, my y's from number 6. And I've already previously typed those in, so I'm going to go ahead and get started on running my linear regression. So I'm going to pick my, let's see, there we go, my x's from number 6, as well as my y's from number 6. I'm going to name this function 6 just in case I need it later. And notice, same exact thing, 0.25x plus 3. All right, so let's continue on. Number 7. Which graph best represents this? Okay, so I'm going to copy that over. And I'm going to look at it. Well, I just need to get that y by itself. So I'm going to divide everybody I see by -5. So I should have a graph with a positive slope and a y-intercept of -3. But I want to verify that I did this math right. So this was a simple problem, but I still want to verify. So I'm going to go into my calculator. I'm going to do a len solve. Remembering, if I see the letter C, that means correct. That means that I did my math correctly, and I transform my equation, and it's still the same. So let me just verify that I did that. And look at that, I see a letter C in there. Therefore, it is correct. All right. So now I'm looking for one that has a y-intercept of -3. Absolutely, it's got to be there. This one doesn't, and it's got to have a positive slope. So the only answer that it could be is answer choice C. All right, next one. A baker determined the annual profit in dollars from selling pies using this equation, where n is the number of pies sold. What is the annual profit if the baker sells 400 pies? So they're asking us to just plug in 400 into the equation. Pretty simple. So there's a lot of different ways we could do this in the calculator. We can do it by hand, but I think we were going to plug it in the calculator anyways. So we could just go ahead and type it in directly, which is most of the time what most people would do. And we'd get 12,800. The other way for us to do this is to go ahead and just store the variable, right? So I would call this function p 8 of x. And that's going to be equivalent to 52x minus 0.05x to the power of 2. It's going to graph it. Now, I could go ahead and look for the table and look where x equals 400, or I can head back over here and I can type in function p from question 8 of 400. Please plug that in for me, 12,800. So my correct answer is definitely G. All right, number 10. So what is the equation in slope-intercept form of a line that crosses the x-axis at 36, that is its x-intercept, and is perpendicular to that line? Perpendicular means opposite reciprocal. So I'm going to take my slope, flip it upside down, change the sign. So now I'm going to go ahead and take that point and my slope, and I'm going to plug it in. Y minus blank equals slope times x minus blank. So I'll fill in all of my numbers. And I ended up simplifying. So now I look, and it looks like J is the correct choice. I want to just verify that this is actually going to be perpendicular. So let me go ahead and graph the original one, and I'll just call this G of 10. Whoops, hold on now. Okay, there's my original equation. So I need to make sure that this guy is going to be answer J of number 10. It's going to be perpendicular. So 9 over 4x minus 81. All right. let us go ahead and zoom out a little bit. I need to make sure. Okay, so look at how they're crossing. Perfect 90-degree angle. They are perpendicular. Their slopes are opposites. So one's negative, one's positive. And they're flipped upside down. Here the 9 is at the top. Here the 9 is at the bottom. So I got this one correct. All right. Next one. Number 11. A student worked out at a gym continuously for 50 minutes. The graph shows the remaining percentage of the workout as a linear function of x, the time in minutes. Which answer choice best describes the domain and range of the function for this situation? Okay. So let's go ahead and do this. I see first of all that this is a continuous function. Therefore, it will look like this. Okay. So now I'm going to look for the point that is the furthest over here on this side, on the x-axis. That's located at 0. Here the dot is filled in, so I put my extra line. Now I look for the highest point on the x-axis, and that's located over here at 50. I put my extra line. Now I'm going to go ahead and I'm going to look for the lowest point on my y-axis, which is also 0, and it's filled in, so I put my extra line. It goes all the way up to 100. Dot is filled in, my extra line. So my domain is all real numbers greater than or equal to 0 and less than or equal to 50. My range is all real numbers greater than or equal to 0, less than or equal to 100. So these guys don't make any sense. It's got to be one of these two. Here in A it says domain goes from 0 to 100. It doesn't. So my correct answer is C. Next one. The graph of the quadratic parent function f was transformed to create the graph of g. Which graph best represents g? So I'm going to go ahead and work this out by hand, and I'm going to show you how to do it in the calculator. So my parent graph for quadratic functions looks like that. Now, they are asking me g of x equals f of x plus 2 minus 5. So inside of f, everywhere I see an x, I'm going to change it to an x plus 2. Now I'm going to go ahead and I'm going to take this and I'm going to exchange it or substitute it in. Notice this is in that transformation form. So we know it's going to be 2 to the left, 5 down. So I can look for 0, 0, 2 to the left, 5 down. 2 to the left, 5 down. That one matches. So if I go down here, 0, 0, 2 to the left, 5 down, nope. 0, 0, 2 to the left, 5 down, nope. So my correct answer should be H. I just want to verify that's what the graph looks like. So I'm going to go ahead and do that. So I'm going to go ahead, I'm going to start a new graph. I'm going to say this is from question number 12. So the function from question number 12 is going to be equal to x to the power of 2. So that's my parent graph. And now I'm going to go ahead and create g. I can type it in exactly as they have it. So g from the question number 10 is going to be equal to f from the question number 10 of x plus 2 minus 5. Question number 10. Oh, excuse me. This is question number 12. I messed up a little bit here. There we go. All right. So now I can see 2 to the left, 5 down, exactly as I predicted. So we got this one correct as well. What I'm going to do is I'm going to go ahead and first get this equation to equal 0. So I'm going to copy it over, and I'm going to ask myself, all right, what can I do in order to get this equation to be equal to 0? So I'm going to go ahead and I'm going to move that 135. Noticing that I'm not really doing anything terribly complicated. Okay, So now I could use the quadratic equation, which we haven't talked about yet, for sometimes crazy roots. Now, one thing I do notice though is all of these are not evenly divisible by the same number. They're not all divisible by 4, 2, 3. I don't see anything in common. So I could go ahead and just do my ABC method, or I could go ahead and try and graph it. I think at this point with this one, because of how big this number is, I want to go ahead and just graph it. So I'm going to say 4x to the power of 2 plus 12x minus 135. And it shows me 1, 2 roots. They don't care about that negative root. They said positive solution. So I'm going to go ahead and do my graph trace. Oh, we keep scrolling up until I get to that positive root. So let's see, we're almost there. All right, there we go. X equals 4.5. Now, of course, we could have gotten that with factoring, but we don't want to go through all of that, especially with a number as big as 135. But my correct answer is 4.5. All right, let's continue on. So, a grill at a barbecue restaurant will be used to cook sausage links that are 2 pounds each and briskets that are 6 pounds each. No more than 120 pounds of sausage links and briskets will be cooked on the grill. Which equation represents all possible combinations of X, the number of sausage links that will be cooked on the grill, and Y, the number of briskets that will also be cooked? So, first of all, they're not asking us about the total number of briskets and sausage. They're asking us to relate this to weight. So, my total number on this side of the equation is weight. Here it says no more than. No more than. So, I can have 120. I can have 119. But I cannot have 121. Now, this X and this Y are counting numbers. These are numbers that I'm using to count how many sausages, how many briskets. However, I'm doing this 120 in pounds, so I have to convert them, meaning I've got to multiply them times their respective weights. So now I look and I say, all right, and I see the only one that looks like it closely approximates this is answer choice B. And there is no way for us to put this information into the calculator. All right, let's look at number 16. Which expression is equivalent to this? Now, the great thing about doing this, we can graph this part, and then we can graph whichever one answer we think is correct, and we can match them to make sure they're the same. So first thing I'm going to do is I'm going to go ahead and continue to work this out by hand. Let me change my color a little bit, get a larger pen. All right. So first thing I see that this is a plus in between here, meaning it is not going to affect anything. So I can just pull everything out of my little parentheses and then start combining like terms. So for this particular one, just because there's so much going on, I'm going to use a chart just to help me kind of keep things organized. So I'm going to do r squared, r's, and numbers. So negative r squared, negative 6r squared. I'll cross those off. 7r, 5r. Let's cross those off. Positive 10, negative 18. Okay, so now I'm going to go ahead and start combining like terms. Remembering, I am not including anything above this pink line. That was just telling me where to put everything. Okay, so I'm going to go ahead and say negative r squared minus 6r squared, negative 7r squared, plus 12r minus 8. Okay, and it looks like I got an answer. So I'm going to look at all these guys over here, trying to figure out which one is closely approximating it. And it looks like this one's probably the closest one. So I'm going to tentatively say our answer is H. But I want to verify this with my calculator. I don't just want to put this answer. I want to make sure this is 100% right. So I'm going to go over here. I'm going to start a new graph. And I'm going to say that this is my function from question 16. I'm going to go ahead and say parentheses 10 plus 7. And I'm going to change it to an x minus r to the power of 2 plus, hold on, outside of my parentheses, plus, open parentheses, negative 6, r to the power of 2, minus 18, plus 5r. I'm going to grab, I did not mean to type all those r's. Hold on. Let's go back to that one. There we go. I meant to type in those x's. Well, actually, let me see if this will work. I don't know if this will graph, but let's just try it out. Okay. I guess not. All right. So let me go back. I'm going to go ahead and change all those crazy r's into x's like they should be. Okay. So it's going to be x squared. X here. And x here. All right. So my original graph should look something like this. Here it is. I'll go ahead and move the little label over, right? All that writing. I want to verify that my answer choice is the correct answer choice. So I'm going to go ahead and say, come on, calculator. So I'm going to go ahead and say here, this was answer choice H from number 16. And I'm going to say that it was negative 7x to the power of 2 plus 12x minus 8. And, now that is odd. I feel like something was typed in incorrectly here. So let me see. 10 plus 7 minus, oh, that's where it is. This is my mistake here. All right, so let me go ahead and just fix that really quickly. So I'm going to go up to my history menu. Let's do f of 16. So this is 10x plus 7x minus r squared plus negative 6r squared minus 18 plus 5x. That's weird that it is not showing correctly. Oh, there's my mistake. Okay, whoops. My mistake was here. I did not put in my 7. So this should have been a 7 up here. And now it matches. Okay. So, Mr. Carmona thought he lost his math skills for a second, but that's all right. We got it. So number 16 is correct. We got that one as well. Let us go ahead and take a look at number 17. So here they're asking us which best represents the solution set of this. Okay. So, first of all, I see that this guy does not have that extra line. Because it does not have that extra line, that means that this is going to be a dashed line only. So that's not this, not this. Those guys are solid. So I look at it again. It says Y bigger. I should be shading up. So this is not shaded up, and this one is. I don't even need to verify beyond that. That is 100% correct. I could go ahead and take a look. I could test a few points if I wanted to in the calculator, but that's not really necessary. Let's go ahead and take a look at number 19. All right. A company collected data for the number of text messages sent and received using a text message application since October 2011. The table shows the number of text messages sent and received in billions over time. The data can be modeled by a quadratic function. Now, that part is important. Modeled by a quadratic function. Something with an x squared. Which function best models the data? Okay. So first of all, x, y, right? Now, here's the thing. This is going to be exactly, 100% exactly like running a linear regression, except we're going to pick a quadratic regression, okay? This is not something I would suggest you do by hand because this is really, really complex, okay? So I want you to most definitely use your calculator on this one. So I'm going to go ahead, I'm going to open up a table. These are going to be my t values from, well, I'll just say my x values from number 19, my y values also from number 19. I'll go ahead and get all of these guys entered. And I'll go ahead and come over here and I'm going to put in their associated values. All right. So now I'm going to go ahead and run my regression. I'm going to say menu, statistics, stat calculations, and usually we go here, but instead I'm going to do a quadratic regression. I'm going to tell it, okay, my x's are the ones from 19, and my y's are the ones from 19 as well. I'm going to save this as function number 19, just in case I might need that later, which we probably won't. I'm going to go ahead and click OK. And it's going to go ahead and spit out an A, B, and C. I'm going to take a look at all of my answer choices. And it looks like this guy is the one that most closely matches. Now, these are usually never going to be exact answers, so you might have to round or things like that, okay? When we're running some kind of regression, especially on stuff that's not aligned, it's probably not going to be an exact answer. Now, I know it's not this. That's got the wrong A. This does not have a B value, and this one has the wrong A. So my correct answer has absolutely got to be B for number 19. All right. So here we go again. The graph of the linear function is shown on the grid. What is the rate of change of y with respect to x for this function? I just want to know the slope. Well, here's the good thing. I could go ahead and select any 2 points on here, and I can calculate my slope. Down 1, 1, 2, 3, 4, 5, to the right. -1/5, or -0.2. I could also take these points and run a linear regression, and it'll spit out that slope as well. So I'm going to go ahead and do that. I'm just going to verify, because again, we could have counted them, right? We don't always have to use this point. Because look at that. That's not really something that I can count, and that's probably going to make some crazy math if I did use it. So instead, I just wanted to count them just to verify. And now I'm going to go ahead and drop them into a linear regression. So I'll say that these were my x values from problem number 20, my y values for problem number 20, and over here was -3, +5, and 3.6, +2. I'm going to go ahead and run my linear regression. Y equals mx plus b. I'm going to pick my x values, remembering, as you can see from this crazy list, I already got way too much going on here. So that's why I always name them using the problem number so it's easier for me to find. This is problem number 20, so I'm going to make sure and select those. I'm going to change this to F20. I'm going to go ahead and save it. And it's going to spit back an equation. -0.2. Exactly what we just found. Okay. So now I'm going to go ahead. I'm going to say that is definitely my correct answer. And I'm going to take a look at the next one. Now, I'm going to look at this. And I'm going to say, okay, well, I don't know which one of these graphs this is. -x squared plus 6x minus 1. I do know that because this is negative, my graph should look like this. So I know for sure it's not this guy and it's not that guy. Now, I got to try and decide in between those two. And they look almost exactly alike, except they go through slightly different points. So instead of driving myself crazy, I'm going to go ahead and just graph this. Let me go over here into my graphing mechanism in my calculator. And I'm going to say this is f from number 21. And this is -x to the power of 2. Whoops. Hold on now. Okay. -x to the power of 2 plus 6x minus 1. And it is, where did it go? Okay, my calculator's kind of glitching here. All right, so I'll just call this Q21. Okay, and this will be negative x to the power 2 plus 6x minus 1. Okay, now I found it. So I'm going to look at this graph. I'm going to scoop it up and I'm going to move it over just a little bit. Okay. Now notice how it's right before there. Okay. And over here it's right after the 0. So I'm going to go back. I'm going to look at this problem. I'm going to look a little closer. That looks like it's right just a little bit before, right just a little bit before. However, this one looks like it's behind the 0 and in front of the 6, the opposite. So they gave us two graphs that look almost exactly alike, and they are not. The correct answer is A, and I verified that because look at that. I have a little bit of space in between it and 0 and a little bit of space in between it and 6, just like I do here. So I verified that using my calculator. All right. Problem number 22. So let's go ahead and read through this and try and figure out what in the world these folks want. A company advertises on a website. A worker tracked the number of visits to the website and the number of clicks on the advertisement. The table shows the data for several days. A linear function can be used to model the data. So here's all of our data. Based on the table, and I do want to make sure that you guys remember this, a linear function. Now, up until now, until we started, so I'm reading through the problem, and I see here that it says a linear function can be used to model the data. Now, I want you guys to remember that whenever you see something like that, that is important. Because up until now, we've only dealt with linear functions. We haven't dealt with quadratics and exponentials. Now, the thing is, there's lots of different kind of regressions. And the very last problem that we just did a moment ago, let me see here. This guy was a quadratic regression, meaning we asked the calculator to find the equation for us. There are other kind of regressions, so you have to pay attention to it. Everything is not always going to be a line. Sometimes it's going to be a quadratic. Sometimes it's going to be an exponential. So here it says, based on the table, what is the best prediction of the number of clicks on advertisement if 1,500 people visit the website? So let me explain what exactly they want us to do. First, they want us to run a regression and get an equation. Then they want us to go ahead and plug in 1,500 for x. Okay? So first thing I'm going to do is I'm going to type in all of this data. Now, that might drive you a little crazy, but for any problem where they're talking about a quadratic or an exponential or anything, you always want to type in all the data. Because if I miss one little data point, that's going to completely throw off my answer. Okay? So I'm going to go ahead and head over here. I'm going to start a new table. These guys are going to be my x's from number 22, my y's from number 22. And let me go ahead and type in all of those numbers. Okay, so I got my x's in. Let's go ahead and put in the associated y's. Okay, I got all of those in. Now I'm going to run a regression. So menu, statistics, stat calculations, and they told me that this was linear. So I'm going to do y equals mx plus b. I'm going to say, okay, my x's were from number 22. My y's are from number 22. And I'm going to save this as F22. Now, this is why this is important, okay? So remember that. All of these are question 22. All of them have a 22 in them. I'm going to hit OK. It's got me this fancy equation. Okay. So now there are two possible ways that I can go about plugging in that 1500. I could, let me go ahead and head back over there. So I could write this equation down manually. I can go ahead and plug in 1500 and do it by hand. I can also graph it after I copy it down and look at the table or any other number of things, right? But we want to do this the easiest way possible. I saved it as, let's see, F22, okay? So I'm going to head over here and I'm going to go ahead and head to a calculator page, F22 of 1500. And look at that. It's going to tell me my answer, F22 of 1500. Now, I could have also have done this in this chart. So let's see. That's kind of I'm not going to go through all that complex craziness, but this is going to be our answer. F of 22 of 1500 equals approximately 83. So if I would have taken that equation, plugged in 1500, done all those things, I still would have arrived at approximately 83. So my correct answer is most certainly H. All right, let's take a look at the next one. So now, I want you guys to notice something about this. Look at these answer choices. This is in what is called point slope form. So traditionally, most people don't really use this because it's kind of like a weird equation. But what I want to tell you about this before we go any further is I just want to give you a little bit of background about this equation. So originally, if you take this equation and you multiply it out, and I'll actually switch the sides here so it'll be a little bit easier to understand. So if I have this equation, which is my slope formula, I can multiply both sides by x minus x2 minus x1. This is essentially point slope form already. They just took off the 2's. It's exactly the same exact thing. Now, what people typically use this formula for is they take any point on the line and the slope, and instead of plugging it into y equals mx plus b, solving for b and rewriting it, they plug everything in here and then they rearrange it until it looks like y equals mx plus b. So for example, on this guy, I can pick any point that I want. Here it looks like they picked 2 and 7. So I'll look to see which one that is. Positive 2. So no. No. There we go. All right. So here we go. So this is the point that they chose to use. Now, the way that I figured that out was I just looked at what points they had. They had a 7 in the X category, a 2 in the Y category. Now, this is a really weird, wonky problem that makes no sense, okay? Because you would never do this in real life. There would be no point to writing this. But unfortunately, this is on the test. So I found my point, and I'm going to look for just one other point, and I see it here. I'm going to calculate my slope based on this. So I'm going to go up 1, 2, 3, 4, 5, and over 1, 2, 3, 4, 5, 6, 7. So my slope is 5 over 7. My point is 7, 2. I'm going to plug those in. Y minus 2 equals 5 over 7 into x minus 7. So I'm going to look at all my answer choices, and it looks like answer choice D is the only one. Now, you might forget all of this information. Totally okay. I never really learned about that equation until I was actually a teacher. I had never saw it before. So if you look at all of the stuff under the linear equations, I want you to take a look at those last two. Notice how they are basically the same equation. Look at that. This part is here, and I'll highlight this so you can see it. this part is here, and that part is there. Same exact thing, they just rearranged it. Now, the beauty of this is you already know how to rearrange stuff, even though we've never really rearranged things that have multiple terms. We've never really done that before. But all you're doing is the same exact thing. If I treated this as just one variable, I can move it over there with ease. So again, all they did was plug in this, this, and this. Okay? Now, the other thing that I could have done was I could have changed all of those in a slope-intercept form, graphed it, see what it looked like, etc., etc., etc. Okay? Or I could have ran a linear regression on this one, or just calculated the equation myself. So lots of different ways, but I think what I just showed you here would be probably the easiest thing for all of us to do. Okay, so let's take a look at number 24. So this one is asking which expression is equivalent to that statement there for the values of x and y where the expression is defined. Fancy way to say, hey, can you reduce this for me? All right, so there is no direct way for us to ask if our answer is correct in the calculator. However, what we can do is we can multiply this, and then we can do all of our simplification, and then we can go ahead and verify that it matches with the calculator. Okay, and we've already done this once today. We're going to do it probably a few more times. So anytime I see stuff on the outside, my first thought is, okay, exponents distribute to exponents. So x squared y to the power of negative 12. All right, I see a negative. I don't like that. I'm going to leave that at the top and move the negative 1 to the bottom. All right, that looks like a final answer to me. So I'm going to ask my calculator, hey, is this the same thing as this? To see if I got my answer right. However, my calculator will not do that unless I tell it x is equal to this, y is equal to this. Now, the process of storing those numbers is too much extra information. So instead, I just take all of the variables, and starting at number 2, I just assign them a value, 2 and 3. Okay. So now I'll go over to my calculator on a calculator screen, and I'll say 2 times 3 to the power of negative 6. And all of that will be to the power of 2. And I'm going to say, hey, calculator, is that the same as this fraction? 2 to the power of 2, all divided by 3 to the power of 12. Whoops. 3 to the power of 12. And it says true. That means I got this one correct. So what did I do? So I did exactly ask my calculator if this was true, if I reduced this correctly. However, I just changed x and y into numbers. I just picked numbers. That's not the values of x and y. Those are just random numbers that I picked. And I picked easy, simple to remember numbers, okay? So this is true. That is the correct answer. So I'm going to look, and look at that. These crazy people didn't even write this in proper math, okay? So this is not how you're supposed to write it. So this tells me somebody who didn't know their math wrote this test. But that is the correct answer based on this. This is going to be equivalent to this. These are the same. I could have also just plugged this in like this and plugged this one in to match it up to see which one was correct. All right, let us keep on going. Let me pick a better red. All right. So, a college student completed some courses worth 3 credits and some courses worth 4 credits. The student earned a total of 59 credits for completing 18 courses. How many courses are worth 3 credits? Okay, so what does this sound like to you? It sounds to me like they are talking about a system of equations. Meaning I'm going to have 2 equations, and I'm trying to figure out when they cross over because that is the answer. So first of all, let's look at this. So 3 credits, I'm going to call those guys X. 4 credits, I'm going to call those guys Y. And remember what I told you, I like to write mine directly on top of the problem just so it's a little bit less confusing. So if I take 3 credit courses, 4 credit courses, and I add them all together, I took 18 classes total. So I'm good with the 18. That 59 is also a total, but that is not number of classes. That's number of credits. So I have to change the classes into credits. I do that by multiplying how many credits are worth. 3x plus 4y. Now, of course, I can solve this by hand by doing an elimination, which is usually what I would do because it's usually a little easier. So I'll go ahead and do this one by hand, and I'll also solve it by calculator. Now, I could go ahead and graph it, look for the intersection, but that's going to require that we solve for y to get y equals mx plus b. Instead, I would use a ln solve, okay? But for now, let's go ahead and deal with this part. So first thing I'm going to do is I'm going to go ahead and multiply by -3, so that way I can get these x's to cancel out. Now I'm going to go ahead and I'm going to add the equations together. Cancel y equals 5. Okay, they made this simple for us. Now I can take my y value and plug it back in to either one of the equations in order to get an answer. However, I see that very first equation doesn't have anything multiplying by y or x. That would probably be the easiest one to use. So I'll say x plus 5 equals 18. Let's move the 5, and I get x equals 13. Now, x's are going to be my 3 credits, y's are going to be my 4 credits. So they took 13 3-credit classes. Now, let's say I didn't remember how to do this elimination, or I was running out of time and I needed to hurry up. Let's go ahead and go over to our calculator. I should be on a calculator screen, and I'm going to hit Menu, Algebra, Solve System of Linear Equations. It's going to ask me. I don't change any of this. I'm going to hit OK. I'm going to type in my equations exactly as I got them. And it's going to spit back the same exact thing that I got, 13, 5. 13 3 credits, 5 4 credits. So we got this one correct. Answer choice A. Let's go ahead and keep going. All right, number 26. The graph of a linear function f passes through this point and has a slope of -3. What is the zero of f? 0. So that word tells me x-intercept. They want to know where does it touch the x-axis. So we have a lot of different ways we can do this. We could go ahead and make an equation and plug in y equals 0. We could go ahead and graph this, and then we can go ahead and look at it. There's lots and lots of different ways. If I was to do this by hand, what I would do is I would say 1, -9, and I would do my slope. So down 3, right 1, which I can't do because there's no more graph. So I'll go opposite, up 3, left 1. And I'll keep on doing that until I run out of graph. Now, smarties will already know that, of course, if I'm looking at this, I see my x-intercept right there. And I know you guys aren't blind and we don't want to waste time. But I did this just to make sure. I see that my x-intercept is located at -2. So there's my x-intercept, -2. My correct answer is J. Now, the other way that I could have done this, I could have used point slope. I could have used y equals mx plus b. So I'm going to go ahead and do point slope, okay? I'm going to show you what we were just talking about. So y minus, hold on, I'll write it as a blank here. So y minus something equals m parentheses x minus something. And I have to fill in those three spaces. So I'll put in my y, my m, my x. Okay, two negatives make a positive. And now I'm going to start simplifying and rearranging to make it look like y equals mx plus b. So notice negative 6, negative 6. So that's consistent. That is correct. I'm looking for the x-intercept. So I need to plug in y equals 0. I'll go ahead and solve for x. Oh, whoops, wrong thing. All right. And I end up at the exact same answer. So as you can see, there's a lot of different ways to do this. What I want you to do, instead of trying to memorize how to do it, is just to put together your own knowledge and your understanding. If you see this and you say there's a line that goes through this point and has this slope, all I need is a point and a slope, and I can start graphing the line. And I can figure out where that x-intercept is. Okay? So for the calculator part, we would have graphed this guy and then looked for its x-intercept. Okay, so let us take a look at this. We have never, ever, ever touched this in our class, and you've probably never seen this before. And I chose to include this because I wanted you guys to take a moment to look at this and to think about it, okay? So they're asking for a y-intercept. Y-intercept means x is equal to 0. So anywhere I see x, I change it into a 0, okay? Now, this is going to take the exponential rules that we already know and put them to use. So I'm going to go ahead and plug that in. All right, so 5.2 to the power of 0. Well, I remember that anything to the power of 0 is still 0. It's still 1. I'm going to go ahead and type that in just to verify. And look at that. And even if I put in any other number, still 1. Always. Unless you put in 0 to the power of 0, which is undefined. That's the only one that doesn't work with, okay? So I put that in, and it's 1. So h of 0 equals 29 times 1, which is 29. My y-intercept is 29. Okay, interesting. This is going to come up later. Now, I could have also just graphed it and then looked at the graph. So I'll go ahead and say that this is function from number 27. And we're going to say 29 multiplied by 5.2, close parentheses, to the power of x. Okay. So I'm going to look. I don't see it yet. So, well, it looks like my graph is getting kind of crazy there as I zoomed out a little. But let me go ahead and do a graph trace. Graph trace. Okay. So that's way up there. And there it gave me my y-intercept. So I could have just graphed it and looked at it. 0, 29. It's located at y equals 29. That's my y-intercept. So lots of different ways. And again, like I said, just because you've never seen it before doesn't mean that you don't already know it. Because you do. Okay? All you have to do is just put together what you already know. We haven't even learned anything about exponentials here. We've never seen an x up here before. But we can still totally do this just knowing stuff we already know. So let's go ahead and take a look at number 28. All right. So now this graph is going to be a little bit unusual for us to figure out. There's lots of different ways that we could do this. And I'm trying to think what is the easiest way for us to do this. So, of course, the first thing that we can very easily identify is these solutions. 0, 0, 6, 0. Okay. Now, anytime I'm running a quadratic regression, I want to find the equation. I always want to have just a few points. I want to make sure I have about 3 or more. So let me go ahead and pick this one as well. Now that I have 3, I can go ahead and run a regression and get my answer. So let's go ahead and run my regression. So I'm going to go ahead and head over here, look at my table. These are going to be my x values from number 28, my x values from number 28 as well. Sorry. My y values from number 28. I'm going to go ahead and plug these guys in. So I'll say 0, 3, 6, as well as 0, -9, 0. Okay, I'm going to go ahead and run that regression. Menu, statistics, stat calculations. This was a quadratic, a U-shaped graph. So I'm going to go ahead and pick my x. Remember what I told you earlier? This list is going to get super crazy. So we want to make sure that we always label them with our question number, x28 and y28. I'm going to call this function 28 as well. I'm going to go ahead and hit OK. And it's going to run a regression. Now, anytime you see one of these e's, that's like times 10 to the power of. That's scientific notation. And this number right here is really close to 0. It's so incredibly close to 0 that we could just say that that is 0. So 1x squared minus 6x. So I look over here, 1x squared minus 6x. So my correct answer is H. Now, the other one that we could possibly do in order to find this is a really long process that we will talk about another day. Okay, let's go ahead and take a look at number 29. So this one they're asking me which one of these expressions is equivalent to this. So I could graph this and graph this in order to verify that they are the same. But what they're actually asking me to do is to factor this. So I'm going to go ahead and do that. First thing I'm going to do is I'm going to look at my equation. I'm going to say, all right, well, I don't really see anything that they have in common. No greatest common factors. So I'm going to multiply A times C. So 24 times 5. So I need two numbers that when multiplied together will give me 120. But when added together, give me -22. Meaning, this is probably two negative numbers, okay? So, I'm thinking about it. So I'm going to say -12, -10. Okay, good. Those are my numbers, -12, -10. All right. So now I'm going to go ahead. I'm going to take my equation and I'm going to split apart that B value. Noticing the only thing that changed was that part that I did in purple. I'm going to take the first two terms and I'm going to factor out anything I can. I'm going to take the second two terms and I'm going to factor out anything I can. However, with the second two terms, I want to make sure if the first one has a negative, I pull out the negative, okay? So -5 into 2x minus 1. Now I'm going to verify that the insides are the same, and they are. So I can combine like terms. All right, so I got it. So let me look. And it looks like answer choice C is going to be the closest. I want to verify this. So let me just go to my calculator to verify for question 29. I'm going to go ahead and take a look at my graph. And I'm going to go ahead and graph the function from 29, if my keyboard would comply with me here. All right, function for 29, 24x to the power of 2 minus 22x plus 5. Okay, so my graph should look something like that. Let me go ahead and add another graph. I'm going to call this one answer choice C for number 29. And I'm going to put 12x minus 5, 2x minus 1. And look at that, it lays directly on top of there. So we did our math correctly. The correct answer is most certainly answer choice C. Okay, so let us keep on going. Let's take a look at question number 30. A system of equations is graphed in the grid. Which system of equations does this graph represent? So, they got a lot going on in this graph. However, the great thing is, all of these are currently listed in slope-intercept form. Meaning, if we run a linear regression, we will get those answers. So, I'm going to do this one by hand, and then I'm going to go ahead and I'm going to do it on the calculator as well. So, first thing, let's go ahead and deal with, I'll call this guy my blue line, okay? So I'll just turn in blue. So, first thing I'm going to do is I'm going to say my slope is equal to 5 minus 3 over 1 minus negative 1. Two negatives make a positive. My slope is equal to 1. Then I look for a y-intercept if I can identify it, which I can. It's positive 4. Or I could solve for it. I'll go ahead and solve for it. So I'll do this one utilizing point slope. So y, and I'm going to pick my easiest answers, minus 5 equals 1 times x minus 1. And I'll say y minus 5 equals x minus 1 plus 5 plus 5. Y equals x plus 4. Noticing that's exactly what we just saw. So whenever I use this point slope form, it allows me to kind of skip the step of having to plug it back in. I could just rearrange it and just basically end up at my equation. Now, I want to do the second one, which I'll go ahead and label as my pink line. And I'll use I'll use y equals mx plus b. So first thing, I'm going to go ahead and calculate my slope. 4 minus negative 2, all divided by negative 4 minus negative 1. Two negatives make a positive. Two negatives make a positive. My slope is negative 2. Now I'm going to pick one of those 2 points. I'll pick this guy because it's got at least one positive. So I'll say y equals negative 2 into negative 4 plus b. And I'm going to go ahead and solve for it. Here I have my b value. Now I have to put it back together. Okay, so if you notice, I have to put it back together using this method, but here I can rearrange it to get the equation directly. So this is really a matter of personal preference. You will get the same answer either way, but I would say go with what makes the most sense to you. So I'm going to look at my answers, and it looks like J is the only one that matches. But what I do want to do is I want to go through and I want to run a regression to verify that I'm doing this correctly. So I'm going to say these are my x's from problem number 30 and my y's from problem number 30. Now I'm going to show you guys something that might trip you up a little bit, okay? First thing I'm going to do is I'm going to do it from the blue line. I'm going to go ahead and run that regression. Of course, this was a line, so I'll do my y equals mx plus b. Oh, this isn't number 5, number 30. Y 30 and x 30. Call this function number 30. Okay. All right, so it gave me an equation. Y equals x plus 4. All right, so that's exactly what we got here. Now, let's say Mr. Carmona was being a little bit lazy. I didn't want to go through all this process of reopening a new page and typing it in. I can go back and I can actually just change the values here. And look at that. It gave me my second equation. This part will automatically update if you change something over here. So if you make a mistake, you don't have to start over. And if you just want to reuse it, you can. For example, like in this problem, we may have to run 2 regressions. So it gave me the same exact answer. So the answer choice that we selected is 100% correct. All right. Let us go ahead and take a look at number 32. All right. So the amount of pet food in cups remaining in an automatic feeder as a function of the number of meals the feeder has dispensed. Based on the table, which function models this situation? So I look at those answer choices and I'm like, oh, I see just ends. Angel, what happened? What's wrong? What's wrong? Okay. All right. So here I look at these. Don't let them trip you up. They're just putting n's to be difficult. Those are the same thing as x's. Now, I look at all these equations and I say, okay, that's a plain x, plain x, plain x, plain x. So this is more than likely a linear function. So I can run a linear regression. Now, I could go ahead and do this by hand and all that jazz, or I could just go ahead and straight run my regression. I'm going to go ahead and do this by hand just so we can have the practice, but we're going to also do it by the calculator. So I'm going to take a look at my numbers and I'm going to say, well, these are probably the easiest numbers because those x's are pretty small. I'm going to first start by getting my slope. So 21 minus 15, all divided by 1 minus 3. Now I have my slope. Okay, let me go ahead and get a point slope. So I'm going to do y minus something equals slope times x minus something else. I'm going to pick the easiest point that I can find. Now this is the magic of knowing what you're doing. I can pick any other point that I want. I could pick these 2 guys down here. I could pick one of the ones I use for the slope. It does not matter. You will come back with the same answer. So I'll go ahead and plug these in. 3, 7. All right. So now I'm going to go ahead and start simplifying. And I'll move that 3 over. And I ended up with an equation. And it looks like it matches answer choice F. However, I just want to verify this with my calculator. So let me go ahead and run my linear regression. And again, I could type over these if I wanted to do that. But because I want to keep this organized, I'm not going to do that, okay? So this was problem number 32. These are my x's from 32, my y's from 32. All right, so 1, 3, 6, 7. And over here, my y's. And I'm going to go ahead and run that linear regression. And of course, I'm looking for the x's from number 32. Point slope is pretty easy. It is. All right, so I'm going to go ahead and use my y. Just for some reason, point slope is something that people get really confused about. I don't know why. And like I said, it's something that I never saw until I was a teacher. I like it, but most of the time they want you to teach it as y equals mx plus b. So I look at this, I got exactly the same answer. So that is correct. Let's go ahead and take a look at the next one, number 33. So here they got a lot going on, like way too much going on. They said the graph of f of x is equal to x squared. And it was transformed to create the graph of g of x, which is f of x minus 9. Which statement about the graphs is true? Okay. First thing, what I want to do is I want to write this out. F of x equals x squared. G of x equals f of x minus 9. These guys are the same, so I can substitute. So now I have my graph. I see that this 9, and let me move that up so we can see it a little better, is actually outside of what could have been something that would have told me about x's. So this is down 9. So I can look at this and I can say, all right, the graph of g is a reflection. We didn't see anything about that. The vertex of the graph is 9 units to the right. We didn't say anything about that. The graph of g is a reflection. Didn't say anything about that. The y-intercept of the graph g is 9 units below the y-intercept of graph f. Yes, that is certainly correct. So the answer choice is D. But let's take a look at this in the calculator. Okay? Now, I'm going to do this in this way because this will apply to more complicated problems later on. But I'm doing it this way just because I want you to get into the habit of doing it this way, okay? So f of 33, this was my parent function, was x squared. All right, we got that. Let's go ahead and make g of 33, which is equal to f 33 of x, minus 9. And look at that. All it did was just shift it down 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. It just shifted it down 9. Exactly what we predicted earlier. Now, I want you to look at how I typed these in. Mr. Carmona took the super smart people route, which is I didn't even try and do the math on this one. I let the calculator do it. I said, this is my parent function, f33 of x, and my function that I want to talk about is just that parent function minus 9. And just like earlier, we could have also plugged in x plus 2 or any other value in here. We could do all kind of transformations with this, and we can let our calculator do the work. So my correct answer is most certainly D. All right. So again, we have another one of these crazy exponential ones. And they want to know the expression if it's equivalent to x to the power of p. What is the value of p? Okay. So now this is an interesting one because this is actually a multi-step problem. We could use NSolve to solve for this. I believe so. We can try. But first I want to solve it by hand. So first of all, I'm going to take this part and I'm going to say x to the power of 22 multiplied times x to the power of 7 to the power of 3 is equal to x to the power of p. That's what they said here. All right, so let's start simplifying. Now, I could go ahead and verify that this piece and this piece are the same by replacing x with the number 2 and just verifying that it's going to give me a true back. I already know that that's correct, so I'm fine with that. But what about this part? X to the power of 43, x to the power of p. So, if the base is exactly the same, we have no other choice but for the exponents to be exactly the same. So that means P has got to be equal to 43. It is absolutely 100% correct that P is equal to 43. Now, let me check to see if this works with NSolve. I'm not sure if it does. All right, so I'm going to go ahead and do an NSolve here. And I'm going to say 2 to the power of 22 multiplied by parentheses 2 to the power of 7. And that's to the power of 3. Okay, is going to be equal to 2 to the power of P. And I'm looking for P. And look at that. It'll give us the correct answer. It is also 43. Same exact thing. So, this is something that for some reason a lot of people get really confused about. But just remember, here's an equal sign. That means whatever's over here all together has got to be the same as whatever's over here. And if we only have one term on each side, and they have the same thing here, in order for this to stay equal, this guy and this guy have absolutely got to be the same. All right, let's take a look at number 35. Okay, so they gave us like way too much information and they're asking way too much about this particular problem. So the graph of linear function k passes through these points and they want to know what statement is true. Well, I could go ahead and graph it and then I could look at them. I could go ahead and solve for it, find the equation. I could run a linear regression. So there's lots of different ways to do this. My initial inclination when I see this is to say, all right, -7, 0, +1, +8. And to go ahead and connect these guys. Whoops. Ooh, let me do that a little bit better. Okay. And I have my line. So now I can answer the questions about it. So I'm going to say, let's figure out what this slope is. It looks like it's 1. Okay, so I would assume that is not correct because that's a negative slope. We have a positive slope. The graph of k passes through the point -1, -8. Let's see. -1, -8. That is incorrect. Okay. The 0 of k is +7. So I look over here. There's a 0 of +7. That is also not correct. The x-intercept of the graph is -7. Yes, it is. Okay. I can also run my regression and look at all of this numerically if I wanted to. But the easiest way to do this is they gave you 2 points. Connect them, make your line, answer the questions. Okay? So, let us take a look at number 36. So for this particular problem, they're asking us to simplify the given expression. So, what I want to do first is I'm going to look at these, and I see that they took out a greatest common factor. Okay, so I'm going to look at this and I'm going to say, all right, what do these guys have in common? It looks like they for sure took out a 21. So I'm going to take out a 21 as well. Okay, and 10 and -3, nothing in common. But they do have a D in common, so I'll pull that out as well. And now I feel like I've taken out the greatest common factor. So I'm going to look at my answer choices. That's positive. They didn't take out everything they were supposed to. So my correct answer should be F. However, I just want to verify this with my calculator. Now, I could go ahead and do a test. I could change the D into a 2 and do it in the calculator screen, but Mr. Carmona likes the graphing because it's easier to tell. So I'm going to go ahead and swing over to my calculator. I'm going to start a new calculator page. And I'm going to go ahead and graph the question from number 36, which is 210 x to the power of 2, because I changed my d into an x, minus 3d. Oh, hold on. 63x. All right, so my graph should look something like that. It's kind of a weird graph. Let's go ahead and type in tab, and I'm going to put answer choice F for number 36. And this is 21x multiplied by 10x minus 3. Hold on, what did I do wrong? 21x into 10x minus 3. Oh, that's correct. Huh. That's very odd. That is super weird. I'm not sure why it's doing that. Maybe it just doesn't like. Huh. So this should be 21x. Let me just type it over. All right. Okay. 21x multiplied by 10x minus 3. Huh. That is really weird that it is doing that. I'm not sure why. Okay, well, I will just go ahead and, okay, that's super weird. All right, okay, so I'll go ahead and just put in another function. Let me just type this in this way. That is so weird that it would not let me graph that. I'm not sure why it's not graphing that, but that is the correct answer nonetheless. All right, let's go ahead and... So, for question number 37, it's asking us to find the value of x as a solution of this system of equations. Now, of course, we can totally do a len solve and get the answer in a matter of seconds. However, I want to go ahead and solve this by hand just to get a little bit of practice, okay? So, I see here that one of them is in standard form, one of them is in slope-intercept form. Typically, what most math people will tell you is that you have to have them both in standard form. You do not, okay? Now, this is for my super smart people. You really don't have to have it in that form, but it's usually a little easier if you do. Now, I see here that this is a -5 up here, and I see that this is a +1 down there. So, what I'm going to do is I'm going to try and get those to cancel out. So I'm going to multiply the bottom guy by -5. So -5y equals, and over here, 25x and 150, 160. All right, so now I have one equation. I'm going to bring down the other one. I'm going to copy it exactly as it is. Okay, now I'm going to go ahead and combine them. I did not mean to multiply by -5y. Whoops. I'll just change the sign. I multiplied by +5. There we go. All right, so now I can go ahead and combine them. So these guys are going to cancel. 3x equals -25x plus 182. I have now something that I can solve. So I'll move my 25x over. I'll go ahead and divide by that 28 to get rid of it. And I don't know what that is, so I'll put that in my calculator. And it's 13/2, which is approximately 6.5. All right, so what I want to do now is I want to do a len solve to verify that my answer is correct. Remembering that I could have earlier just moved this 5x over and then continue with the process, would have got the same exact answer if I moved it into standard form. So let me go ahead and run this len solve. I'm going to hit Menu, Algebra, Solve system of linear equations. Menu 3-2. But it's got to be on the calculator screen. I'm going to hit OK. I'm not going to change anything. 3x minus 5y equals 22. And y equals negative 5x plus 32. And look at that. Same exact x value. I got it right. So I'm going to go back and look. And I got positive 6.5. So I'm going to look. And it looks like answer choice C is going to be the closest. So that's number 37. Let's take a look at the very next one. The table shows a linear relationship between x and y. And here's a bunch of values. What is the rate of change? Rate of change. I want to know a slope. So I could go ahead and just calculate it, and I could also run a linear regression. I'm going to calculate it by hand first. So I'm going to look at these numbers. It looks like these guys are probably the easiest ones to deal with, so I'll pick those. So m equals y2 minus y1 over x2 minus x1. So y2, y1, x2, x1. Let's plug those in. Noticing that I'm writing in my negatives, okay? So 33, 15, negative 6, negative 2. Double negative gives me a positive. All right, so this will be 18 over negative 4. And I can keep reducing until I can't reduce anymore. So approximately negative 4.5. So I look, and it looks like answer choice A would be the closest. I want to run a linear regression just to verify that my answer is correct. So I'll head over to my calculator. I'll start a new spreadsheet, and I'll input my x's from number 39, my y's from number 39. So negative 20, negative 12, negative 6, negative 2, as well as my y values. And I can go ahead and run my little linear regression. The mx plus b, I don't want to use the other one. So of course, like I said earlier, we're going to have all kind of stuff in there by the time you're done taking a test. So you always want to make sure that you are writing in the question number. So that way it'll be easy to find, because otherwise you'll confuse yourself. All right, so I'll change that all to 39s. It's going to spit back an equation. I'm only looking for the slope, negative 4.5, exactly what we got earlier. Okay, so good. We got that one right. Let's take a look at the next one. Which value of x is a solution to this equation? Okay, so first of all, what are they asking us to do? They want to know a solution, a root, a 0, and x-intercept. They want us to basically factor this. Now, there are multiple ways for us to do this. I could go ahead and factor, solve for x. I could go ahead and plug each one of these in to see which one would give me 0. I can graph it, see where it touches the x-axis, and I can also use root solver, I think it's called in the calculator. But let's go ahead and let's practice our factoring, okay? So 5x squared minus 36x plus 36. I look at that and I say they don't have anything in common. So I'm going to go ahead and just multiply out my numbers here. So a times c is 5 times 36. So that'd be 150 plus 30, 180. I need two numbers that when multiplied together will give me 180, but when added together will give me negative 36. So what this tells me is these are two negative numbers, because two negatives multiplied together make a positive, two negatives added together make a negative. So I have to ask myself, what numbers do I think this could be? Well, I'm not really sure, so I'll just try something random. Negative 30, negative 60. No. Okay. Negative. No. of stumped as to what to do with this. So what I'm going to do is Mr. Carmona is going to cheat a little bit. I'm going to type in good. All right, but let me show you my little cheat here. So I'm just going to type in a random equation name. I'm just going to call it W40. And I'm going to put in the number that's multiplying. And I'm going to divide it by x. Now, it doesn't matter what the graph looks like. It's going to look crazy. But I'm going to hit Control T. And it's going to give me all the numbers that are paired together that multiply together to give me 180. Notice how it has them. So I know that I'm looking for those two negatives, right? And Angel just told me these two numbers. And look at that. There they are right next to each other. So all I have to do is the AC divided by x, and it'll give me this list of numbers. This is like a super secret that I think I'm the only person in the universe that does this. But here's my numbers, -6, -30. So we got them. All right, so -6, -30. All right, let's go ahead and break this apart. 5x squared minus 30x minus 6x plus 36 equals 0. Okay. First set, I'm going to go ahead and factor out everything that I can. Second set, I'm going to factor out everything that I can. I'm going to ensure that the insides are exactly the same. And they are. So now I can go ahead and split this apart. I'm going to get one that looks like this and one that looks like this. So, of course, if I follow that pattern, it's always going to be opposite of this divided by that. So 6 over 5, positive 6 over 1, which is positive 6. So I can look at my answer choices. And it looks like J is going to be the only answer. Now, I could go ahead and graph this and verify. I could do a lot of different things, but I'm going to show you something new on the calculator. If I'm looking for only x-intercepts, I can go to Menu, Algebra, Polynomial Tools, find the roots of a polynomial. So I'm going to go ahead and click that. I'm doing 2 degrees. And it's going to ask me to input the values. 5, -36, positive 36. I'm going to hit OK. And it's going to spit back those answers. So it has it. 6 over 5, positive 6. Exactly what we got earlier. Now, of course, I could have also have just graphed this. And this is probably the simplest method, I think, because this is something we do so often. I'll go ahead and do my graph trace. And it's going to start way up there. There's a 0, 1.2, and my other 0 at positive 6. Same exact thing that we got earlier. So we got this. Okay? Lots of different ways. Remember that. You can always verify your work. Okay. Number 41. A part of an exponential function is graphed on the grid. We've never done this before. Which inequality best represents the domain? Now, the great thing about this is domain and range is the same exact concept for every single graph that you will ever see. Doesn't matter what it looks like, doesn't matter what its equation. Okay? So do not ever let yourself get convinced that you don't know something, because you do. Okay? So domain, that is going to be an x value. Only x's. Meaning, B and D are not possible. So I'm going to look at this and I'm going to say, all right, what is the very furthest to the left? I see right here at -2. And then I'm going to go all the way to the right, and it looks like it's right around +1, but that is an arrow. That's a positive infinity. Right? So if I look at my answers, the only one that has a -2 is that guy, this first one. However, I want to verify that it has that symbol, that inequality symbol, in the correct direction. So if I take my little I and I look at it this way, it looks like it's opening towards the X, which is in fact answer choice A. Because that is the same thing as saying all real numbers greater than or equal to -2, which we've already read it that way before. So remember, domain and range, it doesn't matter what those graphs look like, as long as you remember domain is X's, range is Y's. That's all you have to know about it. All right, let's look at the next one. What is the solution to this? All right, so this is a straightforward thing. First of all, I see a negative. That's like having a -1. So I'm going to go ahead and distribute it. I'm going to go ahead and distribute on this side as well. And I'm going to get started on moving things around. I'm going to go ahead and move the 4m just to be difficult. Usually we would move that 6 because it's smaller. Now I'm going to do exciting move. Great divide. So m is equal to -38. Now I want to go ahead and verify this using my calculator. So I'm going to head over to that calculator screen. I'm going to use an NSolve. Menu, algebra, numerical solve. I'm going to type in the equation exactly as I see it. I can go ahead and use an m if I really wanted to, or I could put an x, right? It doesn't matter either way, you just have to keep it consistent. And I'm going to say comma m. Whoops, I used both of them. Let me change this guy to an m. All right. And I got -38. Same exact answer over again. Okay? All righty. So let's go ahead and take a look at number 43. Now, I do want you to keep in mind, every single one of these problems are problems that I took from the 2019 STAAR release Algebra 1. Now, these are only problems that I knew 100% that you should be able to do based on the information you already know. Okay? So, which function is equivalent to this? Now, if you notice, they're kind of playing with our emotions here. This is written in that transformation-y way, right? Taller, skinnier, vertically stretched. 2 to the left, 7 up, right? They told us a lot of information here, but they're not asking us about that. They're asking us which one of these it's equivalent to. So I can go ahead and do this by hand, or I can graph them and match it. But I'm going to do it by hand first. So first thing I need to do is just write it out. Now, whenever you see this on the outside, you cannot do this. The reason is these items are not all multiplied together. They are adding, meaning that this is what they are equivalent to, not distributing that exponent. That only works if everybody on the inside is multiplying or dividing together. Okay? So don't do that. All right. So here I would get 3 times x squared plus 4x plus 4 plus 7. And of course, you could use your box method for this in order to simplify it to this guy. I just did it a way that I was taught when I was younger. X times x, x times 2, 2 times x, 2 times 2. So now I'm going to go ahead and I'm going to distribute in this 3. 3x squared plus 12x plus 12 plus 7. Now I'll go ahead and combine like terms. And I end up at my final answer. It looks like it matches answer choice B. I just want to verify this by making sure their graphs are exactly the same. So I head over here, go to my graph. I will say that this is function number 43. And that's going to be 3 times parentheses x plus 2 to the power of 2 plus 7. It's not even showing me anything, so I guess it's way up there. All right, so I drug it a little bit, and that's where my graph should be. Let's go ahead and add in my answer choice. This was answer choice B from problem number 43. And this was 3x to the power of 2 plus 12x plus 19. And look at that, it lays directly on top of it. So these are most certainly equivalent, and that is the correct answer. All right, so we got that one. Okay. Number 44. Which table shows y as a function of x? Well, functions do not repeat x's. So I don't care about those y's. I only care about my x's. So I'm looking, there's like 4 repeats here, so that's not it. There's a repeat, that's not that guy. Here's a repeat. So my correct answer has got to be H. Simple as that. Remember, function passes the vertical line test, no repeating x's, ever. All right, 45. Which is the equation in slope-intercept form of the line that passes through that point and is parallel to the line represented here? Okay, parallel lines have the same slope. Parallel lines have, ooh, that's ugly. Okay, the same slope. So my slope is going to be 1.2. And I have a point 5, 0, an x-intercept, surprisingly. So I'll go ahead and I'll use point slope for this one. Y minus something equals m times x minus something. I got 3 things I need to fill in. My x, my y, and my slope. So let's go ahead and write those in. My y, my x, my slope. Now I can go ahead and simplify. And now I have an equation. So I look. I got this correct. All right. But what I want to do is I want to verify that these lines are actually parallel. Let's just graph them real quick. If they're parallel, they will never, ever, ever touch. So I'll call this the one for my question, number 45. And this is going to be 1.2x plus 3.8. Okay, there's that first one. Let's go ahead and hit tab. And we're not looking to see if these are going to be exactly the same. What we want to see is that they're never going to touch, okay? And look at that. They are exactly parallel. Even if, let's go ahead and zoom out. Hold on. Come on now, computer. Okay, zoom out. And I'm just going to zoom out a couple times. Look at that. They're never going to touch no matter how far I zoom out. They might look like they're really close, but they will never, ever, ever touch. So I got this one correct. Let's look at the next one. All right. So here it says the graph of quadratic function k is shown on the grid. Which statements are best supported by the graph of k? So they want to know which one of these are true, okay? So I look at this and I say x-intercept located at -3, 0. All right, so let me go ahead and verify that. -3, 0. That is true. It is most certainly touching on that x-axis, all right? So that one's true. The coordinates of the y-intercept are 0, 9. Let me find that y-intercept. So I'm looking here at my y-axis, and it is located at 0, 9. The axis of symmetry is x equals -3. Okay, so I'm going to find my vertex, which also happens to be that x-intercept. I'm going to draw my line, x equals -3. Yes, that's correct. So it's all three of them. So notice, all I'm doing is just verifying information. Let's go ahead and take a look at the next one. Okay, so looks like a crazy problem already. A college student has 2 different jobs. Her combined work schedules consist of no more than 48 hours in 1 week. Which graph represents the solution set for all possible combinations of X, the number of hours she worked at her first job, and Y, the number of hours she worked at her second job in 1 week? Okay, so first of all, they said she can never work more than 48 hours, meaning our graph should end at 48. Okay? So I'm looking at the graph and I'm trying to figure out what this X and Y is. It says the number of hours at the second job, number of hours at the first job. So if I'm only allowed to work 48 hours a week, if I work 48 hours at my first job, I have to work only 0 at my second job. And if I work 48 hours at my second job, I can only work 0 hours at my first job. So I look at this. 0, 48, 48, 0. That's most certainly got to be correct because look at this. My domain and my range only go up to 48 because I can only work 48 hours. But look over here. This graph's going to keep going. Way beyond 48. That's not it. Over here, they shaded the wrong part because they're saying she can work way up there as well. Not correct. And finally over here, again, another arrow. We can't work an unlimited number of hours. Not correct. So our correct answer has got to be